JEE MAIN 2026, 2nd April Shift-2, Physics Section A, Question 43. Let us visualize the setup. We have a large square loop of side L carrying current I. A small circular loop of radius R is placed inside it, such that both loops are coplanar and their centers coincide. The condition is L is much greater than R. The magnetic field produced by the square loop passes through the circular loop. Since R is very small compared to L, the field is approximately uniform over the circular loop. The question states, a circular current loop of radius R is placed inside a square loop of side L, where L is much greater than R, such that they are coplanar and their centers coincide. Find the mutual inductance between them. The options are A, to root 2 mu naught L squared over R, B, root 2 mu naught L squared over R, C, root 2 mu naught R squared over L, and D, to root 2 mu naught R squared over L. The key concept is calculating the magnetic field at the center of a square loop using the Biot-Savart law. Consider one side of the square. The perpendicular distance from the center to each side is d equals L over 2. Each side subtends an angle of 45 degrees at the center. The magnetic field due to a finite wire at distance d is mu naught I over 4 pi d multiplied by sine alpha 1 plus sine alpha 2. For each side of the square, both angles are 45 degrees, giving us the field from one side as root 2 times mu naught I over 2 pi L. Step 1. Find the total magnetic field at the center of the square loop. All four sides of the square are at equal distance from the center and contribute equally. The total field is 4 times the field from one side. So, B total equals 4 times root 2 mu naught I over 2 pi L. Simplifying, we get B equals to root 2 mu naught I over pi L. Step 2. Calculate the magnetic flux through the circular loop. Since L is much greater than R, the magnetic field is approximately uniform over the small circular loop. The flux equals B times the area of the circle, which is pi R squared. Substituting, phi equals to root 2 mu naught I over pi L times pi R squared. The pi cancels, giving us phi equals to root 2 mu naught I R squared over L. Step 3. Finally, the mutual inductance M is defined as flux divided by current I. Substituting the expression for flux, M equals 1 over I times to root 2 mu naught I R squared over L. The current I cancels out, and we get M equals to root 2 mu naught R squared over L. This is our answer. The mutual inductance between the circular loop and the square loop is to root 2 mu naught R squared over L. The correct answer is option D. Here are some exam tips for mutual inductance problems. Remember, M equals flux over current and is independent of the current itself. When one loop is much smaller than the other, the field is approximately uniform over the smaller loop, making the calculation straightforward. Always identify which loop carries the current and which loop receives the flux. Remember the standard result, B at the center of a square loop of side L is to root 2 mu naught I over pi L. Compare this with B at the center of a circular loop, which is mu naught I over 2R. Like and subscribe for more JEE MAIN solutions at MAGPIEHUB.